Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag. Today I'm going to continue on the same topic of lights. So I'm going to go to the next series of that. And this time I'm going to talk about ranges. I want to know different type of ranges. Actually, there are mainly three categories. So I'm going to start one by one. And this series will talk about only one definition and understanding of one part of the range. So let us see what that range is. Before I start off, I quickly want to give you a small insight about some basics. Now, a lighthouse, if you want to recognize a lighthouse during night time, you will do that by using the light, the color of the light, the pattern, the rhythm. That is what we have seen in last two videos. But if you want to look at the lighthouse in daytime, it is mainly the structure. So, which I have already told you before, structure will have a specific height. It will have specific color patterns also. So during daytime, if you switch on the light, the traditional light will get overpowered by the sun. So basically, during daytime, it is more of structure, not exactly the light. It is somewhat like putting your car lights, ordinary lights on your car, but it is of no use. It is not going to help you any vision because of that light. You can still see that something is on, but that's not going to help you because of the sunlight. Okay. So before I start the first definition, this particular episode is going to talk about only one definition. So before I start, let us quickly understand the principle of vision, which is very basic, taught to you in the school also. And after that, what I'm going to do is I'm going to show you how the objects, when you look at sea, how they look. This is on the roads also. If you take a long stretch of the road, the principle is still the same. So two of them, I'm going to show you what exactly it is. Let us look at the first one, which is the principle of vision. Let us say it is daytime. A man is standing here, and I have a lighthouse structure. This structure, please remember, will be recognized by its patterns of color and whatever it is. But if you want to see this, let us assume that the distance between you and the lighthouse is around 20 nautical miles. This is all examples, just for the sake of understanding. I have that lighthouse, and that lighthouse, if I want to see that lighthouse structure in daytime, please remember the first thing I need is a light source, which is your sunlight, which is your ambient daylight. This light is going to fall on that structure. That structure is going to reflect the light, and that reflected light should reach your eyes, which is 20 miles away from him. So this is your principle of vision. Now, there are two constraints or two barriers. Let us see what are those two barriers, because even one barrier is there, you will not be able to see this lighthouse structure. Let us look at the first barrier. The first barrier is a light source itself. Let us say the sun is not visible properly. Why? Because maybe it is covered by dark clouds, so the light is very, very dim. Or maybe you can take a nighttime also, because light source is not there in the nighttime. Okay, no matter what it is, if I cut the light source, you will not be able to see the lighthouse because there is no ambient daylight. The second barrier is the transparency of the atmosphere or the clarity of the atmosphere. If there is a problem with the transparency or clarity, that becomes the second barrier. I will not be able to see the lighthouse structure. So this is your basic principle of vision during daytime. Now let us look at nighttime. I'm just taking a small example of a light, and I'm giving the situation at nighttime. The person is there. The same lighthouse is there. This time it is night. The distance is still the same. Please remember, you should switch on the light, and that light should come and reach you within the 20 nautical miles. Then only you can see that lighthouse because of the nighttime. Now, nighttime, it is only the light. Again, I have two barriers here in the nighttime also. The first barrier is the power of this light. Let us say it is not powerful to reach 20 nautical miles, it is not going to come to you. Now, the second is again your transparency of the medium. During the nighttime also, if I have problem with the transparency, please remember this light cannot be seen by the man. So this is your first principle of vision. Now let us look at the second point which I told you. The second point is how do we see the objects at sea? When you let us say it is an open sea and you have something being seen at the horizon, you will see a very small part of it. Then as you get closer and closer, you will see the bigger part of it, and then maybe the full ship. This is how objects are seen at the sea. Okay, this is the two things. I'm going to show you one more. Same example. Let us say I'm here, and that is my visible horizon. I'll talk about what is visible horizon. You will see a small tip of that vessel. Then slowly, as you get closer, little bit more, and then maybe the full ship. These are the two phenomena you should be aware of before you understand anything about range of lights. The first one was what is the principle of vision. The second one was how we see the objects. Okay. Now we'll come into the first definition. The first definition is your geographical range, or I call it GR. So before I tell you what is GR, let us just try to understand a few bit of things. I'm assuming that my eyesight is perfect and the transparency of the medium, which is atmosphere, is also perfect. So I don't have any constraints or barriers with me. This is just for the sake of explanation. If this condition persists, I have two factors involved which is essential for this definition. Two factors. Let us see what is the first factor. First factor is my height of eye above the Earth's surface. That is the first factor. The second factor is Earth's curvature. Please remember, Earth is not straight, it is curved. So there's a limit to what you can see. And that limit, please remember, you would have seen this all your life. You always want to go to the top floor or the balcony because you can see more. So that means if I stand on the 10th floor, I can see farther than the first floor. This is the basic principle, which is exactly relating to the 2 points, your point number 1 and 2, which is your height and Earth's curvature. What you see around you in 360 degrees, you're standing somewhere in the 10th floor and you turn 360 degrees. What you see is a range, and the distance is what is called as visible horizon. That is what you can see. Okay. And this visible horizon, again, is dependent on the two factors which you just saw now, which is your height and then the radius of curvature. It's very obvious. Higher the height of eye, your visible horizon is larger. The distance what you can see is larger. So basically, geographical range is nothing but your visible horizon. This visible horizon, please remember, can be calculated by a formula. We are not looking at the derivation. It can be calculated, the visible horizon or the geographical range. It is 2.095 square root of h. The answer is in nautical miles, where h is height of eye in meters. So whoever is standing, if I'm standing on 10th floor, I need to use that and use this formula. Okay. Let us see how this affects our range of sighting, this using this visible horizon and GR. Let us just quickly have a look. I'm giving you a small picture of the Earth's curvature. Okay. Let us assume my ship's bridge was 15 meters. So when I calculate, using the GR formula, I get around 8.1 miles, which means that let me assume that I am on top of the bridge. What I can see 360 degrees is got a radius of 8.1 miles. That is what is my radius. This is the radius of my visible horizon. Let me assume that there is a lighthouse whose chartered height is 32 meters. Then when I calculate the GR2, which means that I can have a man standing on top of 32 meters. So what is his visible horizon, or GR? So this is the radius of his visible horizon. I kept both of them facing each other. Why? Because for me, it's as if the vessel is approaching towards a port and this lighthouse. Okay. Now let us continue on this. I'm again assuming a few things. I'm assuming it's daytime. We need to remember what I told you in daytime. Daytime is a structure. I'm assuming it's perfect visibility conditions. That means transparency of medium is good. And my eyesight is also good. Now, can the ship right now in this picture see the lighthouse structure? The answer is no. Because the person standing on the vessel can maximum see only 8.1 miles. And you can see this lighthouse is quite far away from that. I have not mentioned how much, but it's quite far away. So it is called below the horizon. The lighthouse is below or beyond the horizon. That is what is the word used. Okay. So when can this ship see the physical lighthouse structure? So it is pretty simple. Light travels in a straight line, and it is also called as line of sight. This can happen only when both the visible horizons, number one, your vessel, and number two, your lighthouse. Anyway, lighthouse is not going to move, so I kept it exactly like that. But your vessel is going to move, and if you remember, it had its own visible horizon, and that was 8.1 miles. So when exactly the two visible horizons meet each other, that is the time I'm going to see first instant the lighthouse structure. Usually there's a top tip of the lighthouse structure. Okay. So this GR1 and GR2, what I'm calling a geographical range, because of each individual height of eye, cannot change as far as the height is fixed. It is from a formula, it cannot change. So at this moment, you see the top tip of the lighthouse structure, and it'll look as if it is on the horizon, and it is like a rising sun. This is I showed you a picture how the vessel, when it slowly comes, you can see a little bit on the horizon, then bigger. So this is the time when you see at the first instant. Okay. Now at this moment, please look at the distance between the two of them. The distance between the two of them was 20 nautical miles. So actually, with this fixed height of eye of each of you, the geographical range totally is 8.1 plus 11.9, which is 20 nautical miles. Okay. So this geographical range is also called as a rising distance. The meaning of rising distance is you are going towards him. So when you see him at the first instant at the horizon, it is called rising distance. Similarly, the vessel can sail away from the lighthouse. When it's looking at for the last instant, exactly dipping like a sunset, that is called dipping distance, and that is also 20 nautical miles. Please remember, rising and dipping distance are exactly the same for a particular height of eye which is fixed. Now, let us quickly look what happens during daytime. Before you see the sunrise, you should agree that I see something called twilight. Twilight is something, the light which is scattered on the horizon above on the sky before you actually see the light source. Then after that, it comes the sunrise. Similar thing happens to you for anything which is visible. So let me just quickly show you. This is the vessel, and if this is the visible horizon, initially you will see the top tip of the lighthouse. It is called rise and dip. Then this light will start growing slowly as and when you keep coming closer. Now please see this. Let us look at nighttime. Please remember, nighttime there is no sunlight and there is no ambient daylight also. That means now, if you still want to rise and dip this light, nighttime is only the light. You should have the light on. And this light, please remember, the GR1 and GR2 are not going to change. They're exactly the same. This light you will feel as if it is at the horizon. You will feel as if it is not at the horizon. Please remember, it is like a rising sun, or it can be like a dipping also, and the distance between them is still 20 nautical miles. So this can happen in the nighttime also. So just look at this. Please remember, you will see a loom of light before actually rising and dipping of the light. This is what happens during the nighttime. Something similar to what I've shown you here is in the nighttime, you might first see the loom. That means on the sky you will see it scattered light, and then after that you will see the rise and dip. So this is what is the principle regarding geographical range. Please remember, this is the first definition. What I've done is the first definition. So first definition talks about whatever you are seeing at the horizon. So if you see any light or lighthouse structure, the first instant at the horizon, it is called rising and dipping. Now, this was the first definition which I have completed. I'm going to come back with two more modules of this, and I'll talk about the rest of the two definitions that will complete the whole set for your lights, which is used in your chart work calculations. Keep watching Jal Prayag. Until then, Vanakkam, Namaste, Namaskar.